Hi everybody. What I'm going to present now is the fifth use case of the SmartEdge project, and is about head and neck rehabilitation. So before diving into the technology, a very brief mention of why we have tackled this domain. First of all, context related, we have that the assessment in the practices of head and neck rehabilitation are done still, as of today, by hand, having some subjective evaluation, generating unstructured data that have and that are affected by like not easy knowledge transfer. So everything is, let's say, embedded between the documentation and the therapist with punctual intervention. So to approach this domain with the technology that we are developing in the context of the SmartEdge project, and leveraging what's mentioned before by our colleague Darko, so having semantic seamless integration, we have several nodes that we imagine to deploy to apply to the patients to collect information. The step zero of all of this is clearly to allow the technology to blend together, so to allow a semi-automated devices discovery, so that either components from the same network or from other parts of the system can join and live seamlessly. So this is not our first project that involves wearables. And in the past, we have well learned that with rehabilitation of sport measurements, the positioning, the wearability is non-trivial. And fourth, what we are setting as a first step is to identify the sensors and then to place them correctly. But this time we want them to have a wearability that is addressing a phase that is semi-automated. And fourth, leveraging the inverted kinematic chain, we want the patient just to put them, patient or the therapist, put them on, so that with simple movements, the sensor will coordinate and automatically understand where they are placed and with which orientation, so that after this very easy setup phase, the sessions and the therapist can start in a very automatic way. Now, clearly, once they have understood where they are, and for this very use case of the neck rehabilitation, we have envisioned collaborating with the therapist that the minimum number of sensors that are available that we need should be 3. All right, so position 1 on the top or on the back of the head, and 2 around the shoulder area. We have the identification, and then things that can happen would be, for example, one battery runs out, or the sensors of the device, the nodes, starts giving like wrong inputs that are detected by the, for example, tablet in this case, that is the local controller. And fourth, the sensor needs to leave, or it just commits mutiny, and we are left only with 2 operating sensors. At this point, thanks to the semantic infrastructure that we have set in place, a new sensor could seamlessly join the network, and understanding where the sensor is going to be placed, which functionality needs to solve, and blend in, so that all of the architecture and all the practices will not be affected. Clearly, there is also another case where in the situation where we have more components of the same subsystem, and we need a migration of one sensor due to, for example, sensor A has many capabilities, and we need him in area B, so that we can replace him with a simpler sensor that maybe is missing some capabilities. This also will be possible and will be coordinated according to the very specific need of the microflow that we will have designed at the design level, at the orchestration level. Now this is a bit more complex overview, and this will help us to understand which are the components. All right. So far we have described the component that are the nodes, the simple reactive nodes that are weared by the person. They are connected via Bluetooth and coordinated with a tablet that actuate basically as interface between the therapist and the patient, and allows to execute and register the exercises. On the screen of the tablet, there will be a 3D avatar that will serve as a guidance for the patients but also as a monitoring, 3D monitoring that gives real-time feedback to show what they are actually doing and to close the feedback between doing and seeing themselves. So far we have, as I mentioned, reactive sensors, so the wearable nodes. And then we have a bit more complex, and we refer to it as a coordinator, which is a local integrator of the simple service of the simple sensors that can interact with one or more or coordinators, which in this case, for example, we have a Raspberry Pi that in a further stage of this use case, for example, envisioning a pointer that may project on a white wall in front of the patient a path that the patient is required to follow with the neck, so drawing specific angles defined by the therapist. In this case, we have a multi-smart device coordination with some requirements of near real-time performances. Therefore, in our stack, we envision a connection via RTI, so real-time public subscriber in the very specific case. And even here, this falls under the case mentioned before, where we can have sensors migrating from one area to the other of the same subsystem. Now, going higher on the abstraction level, we can find the orchestrator, which is the smart node that contains, for example, the patient data. We have employing some databases that are GDPR compliant with privacy preserving features that allows us to define with the Mendix that we have heard before, the nanoflow, which defines basically which exercises and how the whole pipeline needs to be semantically described and then actuated by the orchestrator. And the other functionalities that are also like dedicated for example, therapists to do further analysis with the data acquired. So all of this is pretty interesting, yet it demands quite interesting heterogeneous technological stack. I will not go too much in detail, but as you can see, so far we have covered a good part, so from the sensor till the orchestrator vertically, and we have already like a pretty meaty set of libraries and technologies that we are integrating. And well, that's pretty interesting and satisfying challenge to deal with. Now, clearly we can integrate different typology of sensors. The one we prefer to start with is the Nordic Thingy 52. We selected this specific sensor given the number of inputs that it can provide. For example, we can have gas sensor, pressure, luminosity, gyroscope, accelerometer, and so on, so that we can put on this sensor several hats. Further in the project, we will also have heterogeneous simple sensors so that we will be able to show that, well, when a capability is not able to be provided, then there will be an intelligent semantic swap between the objectives, between the objects, and how it will be, let's say, seamlessly handled according to the recipe provided. Now I will take just a little bit more of time showing you a short demo of the data acquisition and integration of these three sensors. I just cut the connection and the alignment to save some time. And as you can see, this is just like a 3D avatar that is replicating the movements acquired by the sensor. Now, you will ask why, if we are checking the neck, we need three sensors. Well, that's a very good question. 80% of the neck exercises, indeed, they focus only on the neck and on the head. But if shoulder move, they give, of course, an input that in this case would be negative, which indicates a compensation for the basic exercise. And this is like very valuable information, piece of information for the therapist to see how actually a patient is progressing on their therapy, and even how they are trying to compensate, which can be synonymous of pain and other factors. So now, following on this, I believe today there's not much more time, but switching off one of these sensors and turning on another one, we can see that there is a seamless mechanism that reintegrates stops the acquisition and restarts with the new sensor providing the same set of data. So as mentioned before, it's kind of a long path. And here you can have like a short list of elements which identify the currently ongoing works and future works that, of course, envision the integration with the works provided by the other partners of the consortium. And with this, I would love to leave the stage for questions. Thanks for listening.